Hello my beautiful students, so welcome back to KCET Masterstroke series. So today we are going to discuss the aldehyde, ketone and carboxylic acid chapter in this series. So yes, without further delay, let's get started. So here ABHYAS KCET test series, yes, if you have already taken, very good, but if you're really working hard, then please to understand your position, take this KCET test series that will help you to understand where you are actually standing right now in order to prepare for your upcoming KCET examination. It will give you 35 mock tests and it will give you chapter wise previous year questions as well. So yes, without further delay, take this test series. So yes, in today's session, aldehydes and ketones, first we will study here nomenclature, structure and preparation of aldehydes and ketones we will study. In preparation we will study this preparation of aldehyde ketones, both preparation of only aldehydes and preparation of only ketones. Okay, let's start with the nomenclature. So very little you have to remember about the nomenclature. So this is acetaldehyde, benzaldehyde. This particular thing you can see beta bromobutyraldehyde. This particular thing sometimes they ask the question in KCET with respect to the nomenclature itself. For those particular cases, please remember a few things. Okay, these are the acetone, some ketone names are there. Okay, here comes the entire list that you will get already in your NCERT as well. You can just go through once. Next, one important thing that I need to tell, that here this particular link you can see just below my video, or any class you are doing in Masterstroke series, any video, maybe physics, maybe chemistry, maybe mathematics, biology, just below the video you will get this link. Okay, so once you will click in this link, you will get the chance to attend a free mock test. Okay, free mock test for KCET level. So yes, once you will just click it here, you will get this page opened. Here you will put your mobile number and the OTP will come. So once you will just put your OTP, this particular page will be opened up. Okay, this is your free mock test provided by the Deeksha Karnataka channel, so that you people can get a proper idea where actually you are standing right now. So yes, without further delay, attempt this test and comment me below how much you are getting in chemistry. Yes. So let's proceed. So here we will discuss about the structure. So carbonyl carbon is basically sp2 hybridized, and hence it is a planar structure, right? And in planar structure, the p orbitals, they are perpendicular to that of the plane. These perpendicular p orbitals, they overlap to give you the pi bond. Okay, so as you can see, overall the angle in between them is 120 degree as they are trigonal planar. Okay, and structure, if you just analyze this, they can have the resonating structure. The pi bond can give you the charge separated version. Carbon will get the positive and oxygen will take the negative charge separated version. Okay, next here you can see preparation. We will study preparation of both aldehydes and ketones, only aldehydes and only ketones. Okay, so whenever it comes to the matter of both aldehydes and ketones, we can proceed with oxidation of alcohol, dehydration of alcohol, and from hydrocarbon. Okay, this also we will study only aldehyde from acyl chloride, from nitriles and esters, and from hydrocarbons. Only ketones from acyl chloride, from nitriles, and from substituted benzene. Here both aldehyde and ketone you can see. From hydrocarbon we can proceed with ozonolysis and hydration of alkynes. Okay, here only aldehyde you can see. From hydrocarbons, whenever we will study oxidation of methyl benzene, chlorination of side chain, and Gattermann-Koch reaction. One by one we will proceed, don't worry. First we will do this, then this, then this, one by one. Okay, so yes, let's start preparation of aldehydes. As you can see, by oxidation of alcohol, dehydration, hydrocarbon. So from hydrocarbon, what was there? Ozonolysis and hydration of alkynes. First we will target this zone. Okay, yeah, let's start. So let's say I have to make I have to prepare both aldehydes both aldehydes and ketones. Okay, so now let's start from oxidation of alcohol. So let's start from alcohol. Let's say I'm having ROH, okay, maybe 1 degree or maybe 2 degree, RCR, here also OH. So for both the cases, okay, if you give copper at 573 Kelvin from alcohol, from 1 degree, you will end up with aldehyde, from 2 degree you will end up with ketone. Okay, we did this reaction in the alcohol chapter as well, so you can definitely just previous lecture, you can just go back there and you can check once. Okay, next we will see dehydration of alcohol. So dehydration we can proceed with, let's say one more thing, let's say ROH I am giving. This is the oxidation method actually. One more oxidation method if I proceed with, let's say R. Here let's say I am giving PCC, okay, pyridinium chlorochromate, or I am giving CrO3. Okay, this is also the oxidation reaction that will also give you either alcohol, aldehyde or ketone. 1 degree will give you aldehyde, 2 degree will give you the ketone. Okay, so now from the hydrocarbon, let's say I am having C double bond C, alkene group. Okay, I can simply proceed with the ozonolysis reaction. I can give O3 and Zn in presence of H2O. I will end up with either aldehyde or ketone. Let's say I am starting with alkyne. So alkyne, let me just give H2O in presence of H plus and Hg2 plus. Hg2 plus. So this is basically oxymercuration, demercuration. Oxymercuration. We will see the example of this as well. And demercuration. Okay, one of the most important reaction. So these are the things by which you can get both aldehydes and ketones. Okay, now one more thing that we are definitely going to start a new series, that is KCET. So now you may have the question, what's the difference between KCET and ABHYAS KCET test series, right? So in KCET batch, they are ready to provide you a complete structured crash course. In ABHYAS KCET you will get the mock test, right? That is definitely going to be beneficial for you. But KCET, whenever you are getting both of them, means ABHYAS KCET test series and KCET, in KCET they are providing you 30 days live online crash course, okay, where expert teachers will be there. You already know the name of the teachers, and they will give you the previous year question with solution, complete syllabus revision of PU1 and PU2 by expert teachers, as well as a doubt solving session, and you can see the chapter wise KCET PYQs in the test format you will get, and full length KCET mock test you will get out of it. So the cost is only 2499. So this particular thing will be eligible until certain time. So please make sure that you are taking it right now so that you can get the proper benefits of it. So yes, without further delay, let's start. Here we will proceed with the preparation of aldehydes. So preparation of aldehydes, first will come with from acyl chlorides, from nitriles and ester, from hydrocarbons. From nitriles we will study Stephen's reaction and Dibal-H. Okay. Next, from hydrocarbons we will study the oxidation of methyl benzene and the chlorination of side chain. Okay, Gattam and Koch reaction as well. So let's proceed with this reaction. Oxidation of methyl benzene can be of ATAD reaction, and use of CrO3 also we can proceed. So let's go ahead with the reaction. So yes, preparation of aldehydes we have to start. So yeah, RCOH, right? Sorry, RCHO. So RCHO you have to prepare. Okay, so from where I can start? Okay, let me see the first reaction. From acyl chloride, right? Okay, so from acyl chloride means benzene with COCl, right? Benzene with COCl. Okay, so from here to here, okay, H2, I am giving PD in presence of BaSO4. So what is the name of the reaction? Yes, the name of the reaction is Rosenmund. Okay, reagent, very important, remember this. Okay, next, from where we will start? From nitriles and esters, Stephen reaction and dival H. Okay, so we will start with RCN. So we will start from RCl. So RCN, first let's proceed with the Stephen's reaction. What is the reagent? SnCl2 in presence of HCl, right? You will end up with imine, RCH double bond NH. Okay, this is imine. From here to here, just give H3O plus. Okay, what is this reaction? This is basically your Stephen's reaction. Right, now we can proceed with the dibyl H as well, that is diisobutyl aluminium hydride. Okay, so I can give aluminium hydride isobutyl whole twice, right? First this a little bit water, second. Okay, this is your dibyl H, that will also give you the aldehyde group. Okay, next, what was the next? Okay, from ester, let's proceed with ester. So RCO O R prime. So if you give again dibyl H, if you give dibyl H and water, that will give you the aldehyde. Okay, so now I guess hydration of methyl. Okay, now from hydrocarbon, oxidation of methyl benzene, you can see ATAD reaction and use of CrO3. Let's do them. So first we will proceed with the ATAD reaction. So from oxidation of methyl benzene, right? So let's start with the methyl benzene. I am having CH3. I have to give chromyl chloride out of it. Please remember the reagent, that is CrO2Cl2 in presence of carbon disulfide media. Okay, so it will give you this type of complex CHOCrOHCl2. Okay, whole twice. This type of complex it gives. Now on being treated with H3O plus, you will end up with the benzaldehyde. Okay, this is your ATAD reaction. Okay, one more thing, let's proceed with the side chain chlorination. Okay, let's say I'm again having methyl benzene or toluene. Okay, so in toluene, if you do 2 times chlorination, Cl2H nu. Okay, 2 times chlorination if you do, then you will end up with benzene with CHCl2. Right, further if you just treat this with H2O, okay, in 373 Kelvin, you will end up with aldehyde. Okay, the final one is Gattermann-Koch reaction, right? So Gattermann-Koch reaction, GK reaction, you have to start from benzene. Okay, direct, I can give the reagent. Let's say I can give CO in presence of HCl, okay, and some anhydrous AlCl3 I can give, or CuCl, that is a reagent. Okay, so this is your Gattermann-Koch reaction. Okay, yes, this is the entire preparation of aldehyde. Okay, so I guess it is clear to you. Let's proceed. So preparation of ketones. See here you can see from acyl chloride we can start, from nitriles, from substituted benzene. Okay, so let's do it. So from acyl chloride, right? So I am starting from R prime CO Cl. Here dialkyl cadmium I will give, R2CD dialkyl cadmium. I will end up with R prime COR. This is my ketone. Right, now we can start from nitriles, right? Okay, so CH3, CH2, CN, that is nitriles. Okay, here I am giving, let's say C6H5 MgBr, benzene with MgBr, C6H5 MgBr. Fine. So definitely here also you will end up with CH3, CH2, C, here double bond N MgBr, and here you will get a benzene ring, right? Further you give H3O plus. Okay, so this entire thing will be gone, you will get one oxygen out there. So CH3, CH2, C double bond O, here one benzene ring. So this is one ketone as well. Okay, one more, that is substituted benzene. Let's say I'm proceeding with phenol. Okay, I am giving here RCOCl in presence of aluminium chloride. Okay, I will end up with, this is Friedel-Crafts acylation reaction basically. I will end up with para substituted COR. Okay, this is Friedel-Crafts acylation. I guess this is clear. This is the all probable preparation of ketones. Okay, let's proceed. Some PYQs are there. The oxidation of toluene to benzaldehyde by chromyl chloride. Yes, what type of reaction? Airtight reaction. Okay, proceed. One more question. PYQs. Okay. CH3CN in presence of sodium C2H5OH. Okay, let's do one by one, step by. Okay, so CH3, I am having CN. Here I am giving sodium in C2H5OH, right? So I will end up with CH3, CH2, NH2. Now here what I have to do? I have to give HNO2. HNO2, nitrous acid, then this NH2 group will be converted to OH, CH3, CH2, OH, right? Further what I have to give? Copper oxidation. Okay, fine. So I am giving copper, this is 1 degree alcohol, right? 1 degree. So if you give copper at 573 Kelvin, then this will be converted to aldehyde, CH3, C double bond OH. That's it. Okay, so what they are asking? C. This is your C. So option B is going to be the correct answer. I guess it's clear to you. Let's proceed. Okay, one more problem. Okay, this is basically oxymercuration, demercuration. In oxymercuration, demercuration, what happens? The OH is getting added in the intermediate carbon. So in this triple bond containing carbon, any one of this will get the OH. So this particular carbon is very much stable because of the resonance ability of the benzene just beside it. If you see the entire mechanism of OMDM, that will be even more easier to understand why here the OH will be attached. Okay, so I am not going for the detailed mechanism here, I am just showing you the only answer. Okay, so what is the question? pH C triple bond C CH3. Here if I give Ag2 plus in H plus, so this is basically OMDM, oxymercuration, demercuration. You will end up with this type of system. pH along with C, here you will get OH, here double bond, here CH, here CH3. Okay, now here it is not the end, because here this functionality, if you just look properly, okay, this is basically enol. Okay, so enol will tautomerize, right? Enol will further tautomerize to give you the keto form. Okay, so I can write keto-enol tautomerism. Tautomerism. So keto-enol tautomerism will give you pH C double bond O CH2 CH3. Now look for it. I guess option A. Option A is the correct answer. Okay. I guess it's clear to you. Let's proceed further. Okay, this is the physical properties. Boiling points of definitely alcohol is greater than that of the aldehyde or ketone, then ethers, because of the maximum possibility of making hydrogen bonding. If you just look for the solubility, lower members of aldehydes and ketones such as let's say methanol, ethanol, they are basically miscible in water, okay, because they have the capability to form hydrogen bond with the water, but whenever the alkyl chain itself it enlarges, then those cases the hydrophobicity increases, right? So solubility in water decreases, right? Now aldehydes and ketones, they are fairly soluble in any organic solvent like benzene, ether, any kind of chloroform, methanol, they are nicely soluble in them. Okay, I guess it's clear. Let's proceed. Okay, here we will study the aldehydes and ketone physical property and chemical property. Okay, physical property we already did, sorry. Now chemical property we will study nucleophilic addition, reduction and oxidation. Okay, reaction due to alpha hydrogen. Let's proceed. Other reactions are also there. Chemical reaction of aldehydes and ketones. Here it's very important portion. First is nucleophilic addition, reduction, oxidation, reaction due to alpha halogen and other reaction. First we will focus on the nucleophilic addition. Okay, so many things will come. Here comes the entire chart, one by one we will study. Okay, so one by one we will study. You can see nucleophilic addition, definitely we are going to start first. These are the option: addition of HCN, NaHSO3, Grignard reagent, alcohols and ammonia we will add. Reduction to alcohols, reduction to hydrocarbons. Here in oxidation we will study Tollens test, Fellings test and oxidation of methyl ketones. Here reaction due to alpha hydrogen, that is basically aldol condensation, and we will proceed with the cross-aldol. Other reaction we will study Cannizzaro and some electrophilic substitution we will study. First let's proceed with the nucleophilic addition. A lot of reactions are there. Addition of HCN, very important. Addition of NaHSO3, very important. Grignard also. Addition of alcohols and ammonia. Let's proceed. Okay, so here let's say I am having C double bond O. So here we will do the nucleophilic addition reactions. Okay, first we will proceed with the HCN. It's very important, my dear. Any kind of, they can directly ask you the question that in board examination, that you can directly show the nucleophilic addition mechanism in CO. Okay, or they can ask you that write down the nucleophilic addition mechanism of HCN. Okay, or they can ask you in KCET itself that once you are adding a nucleophilic addition of HCN is taking place, means in CO plus HCN, okay, what is the product that is formed? Okay, so one very important product will be formed out there, that is cyanohydrin. Okay, let's see. So let's say I am giving here HCN. So once HCN you are giving, so CN minus will be attacked here, this will be opened up, this double bond will be opened up. You will get a tetrahedral type of intermediate in between. So once you are just writing in a detailed answer for your board examination, so mention that you will proceed through a tetrahedral intermediate. Why it is important? Because carbonyl carbon is sp2 hybridized, right? Means it's planar. So once the nucleophile will attack here, the planarity will be broken, it will go tetrahedral, it will go out of plane. Okay, so it will proceed through a tetrahedral intermediate towards the formation of the cyanohydrin. Okay, so here you can see I am directly writing. Here you will get this type of thing. Same carbon containing OH and CN, that is called cyanohydrin. Okay, next we will proceed with the NaHSO3. This is also very important. I am telling you why. So first, if you give NaHSO3, again this will undergo some nucleophilic addition reaction, nucleophilic substitution, nucleophilic addition reaction, and it will give you a tetrahedral intermediate. Further, one proton transfer takes place. OSO2 Na. Okay, so these particular thing, Okay, let me just explain you a little bit. If you are having a mixture of aldehyde and ketone, so this particular nucleophile is considerably big, so it will react with the aldehyde majorly. It will not react with the ketone because of the steric hindrance. Okay, so nucleophilic addition rate is more in aldehyde because here I am facing less steric hindrance and electronic effect as well, lesser electronic effect, right? So now if you are having a mixture of aldehyde and ketone, and if you want to purify it, just give some NaHSO3. It will selectively react with the aldehydes and it will make this type of compound, and that forms beautiful crystal. So once water soluble compound. So once you are just once the reaction is done, just take the water out in your solution. Just at below the ketone will be there in your container itself. So above the solution will containing this thing. So from the solution you give some dilute NaOH or dilute HCl. So that will give you back the aldehyde compound. Okay. So this particular mechanism is used for the purification. Okay. So purification, whenever you are having the mixture of aldehyde and ketone. Okay, remember this thing. It's very important for your board examination, and overall in the KCET also they can ask you what is the reagent that can be used for the purification. Let's proceed further. Okay, if you give Grignard reagent, let's say I am giving RMGX and in presence of, let's say, H3O plus. Okay, so here you will end up with one alcohol. Okay, now let's say you are giving some alcohol. This is also important reaction because here you will get the acetal formation, R prime OH. One time I am giving R prime OH in HCl. Okay, so what you will get, C with OH with OR prime. Okay, this particular thing is called hemiacetal. Hemiacetal. Further you give R prime OH. Okay, further if you give R prime OH, definitely in presence of some H plus, it will form the acetal. Okay, this will give you the acetal. Okay, so one thing that if you are starting from aldehyde, it will give you acetal. If you are starting from ketone, it will give you ketal. Okay, that's the thing. Next, we can get the Skips base as well. We can treat this thing with the derivative of ammonia. Let's say, see, NH3 is the ammonia, right? One hydrogen, let's replace by a group Z. Okay, so let's say H2NZ. Okay, so you will get this type of thing. C here OH, here NHZ, and here two bonds. Okay, so further this will give you C double bond NZ. Okay, this thing. What is this? This is basically substituted imine. C double bond NH. This is imine, but here in place of H you are having Z. So this is substituted imine. Okay, or you can call it Skips base. Okay, very important. Now one more thing I can show you here, that Z can be different group. With respect to that you can get different products. So here you can see Z can be ammonia as well, you will get directly imine. Z can be R as well, you will get substituted imine, that is Skips base. It can be OH as well. Okay, you will get oxime. It can be NH2 as well, you will end up with hydrazone. Like that you can get this type of thing. Okay, I guess it's clear. Let's proceed. We will proceed with the reduction reaction now. So in reduction reaction, here you can see reduction to alcohol and reduction to hydrocarbon. In reduction to hydrocarbon, we can proceed with Kistner and Clemenson. So let's proceed. RC double bond O, let's say I'm having. Okay, first reduction to alcohol. What I have to give? I can give lithium aluminium hydride, or I can give sodium borohydride. Okay, I can end up with alcohol. fine. Now if I want to proceed with Clemenson reduction, what is the reagent? Zinc amalgam ZnHg in presence of HCl, right? It will give you the hydrocarbon. Okay, this is your Clemenson reaction. I'm just writing CR, means Clemenson reaction. Okay, one more thing, that is Wolff-Kishner reaction that I can proceed with hydrazine, right? I can treat this thing with NH2. Okay, so this will give you the hydrazone at first, that is C double bond N. C double bond N NH2. Okay, this is your hydrazone, right? Just now we studied, this is your hydrazone. Now if you give KOH in ethylene, okay, this will give you the hydrocarbon CH2, okay, plus N2. This is your Wolff-Kishner reaction. I guess it is clear to you. This is all about the reduction. Okay, let's proceed. Here we will study the oxidation. So oxidation, definitely tollens, Fellings, and oxidation of methyl ketones we will study. Okay, so here a lot of things I have to tell. At first, just let me show you the general reaction. So let's say I'm having RC double bond O H. Okay, so if I give Cu2 plus in presence of OH minus, alcoholic media, okay, so that will give you the oxidized version of aldehyde, that is carboxylate, RCOO minus I will get, that is the oxidation, plus Cu2O, that is the brick red precipitation you will get, okay, plus H2O. Here you will get brick red precipitation. Okay, so this test is basically Fellings. Okay, let me just write it down here. This is basically Fellings. Let me write FT only. Okay, now let me explain what is basically the Fellings test, how it is performed. Okay, so Fellings test, it involved Fellings reagent A and Fellings reagent B. Okay, so what is Fellings reagent A? This is basically alkaline. This is basically alkaline sodium potassium tartarate. Sodium, I'm just writing it in short, potassium tartarate. Okay, and sometimes we call it Rochel's salt. Okay, now what is Fellings B? Fellings B is basically, Fellings B is, Fellings A, just a minute. This is your Fellings B, just let me just change the name. This is your Fellings B, and Fellings A solution is basically something else. Okay, so Fellings solution A is basically your copper sulfate, CuSO4.5H2. Okay, so Fellings A is your copper sulfate and Fellings B is basically your alkaline sodium potassium tartarate, that is also called as Rochel's salt. Okay, now you add them in 1:1 ratio. You add them in 1:1 ratio and it will give you a deep blue color solution. Okay, it will give you deep blue colored solution. Now when this deep blue colored solution will be added with any kind of aldehyde, when it will be added with any kind of aldehyde, you will get a little bit heat may be needed, you will get the brick red colored precipitation. Okay, brick red color precipitation of this, okay, Cu2O. Okay, then only you can tell, yes, my compound is containing some aldehyde group. I guess it's clear. This is all about the Fellings test. Now let's proceed further with the tollens. Okay, so yes, so this is basically ammoniacal silver nitrate. Okay, so it forms a complex, that is AgNH3 whole twice overall charge come positive. This in the ammoniacal medium. It will give you the oxidized version RCOO minus plus Ag precipitation plus ammonia plus water. Okay, so this is basically silver mirror precipitation. Silver mirror precipitation. That is the observation that you should get in the tolerance test. Okay, so here a little bit, let me just tell what is the reagent, tolerance reagent. Tolerance reagent is basically ammoniacal AgNO3, silver nitrate solution. Okay, that will give you some silver mirror precipitation. That is your tolerance reagent. I guess this is clear to you, all the Fellings and tolerance test. Okay, one more thing that I want to proceed with. That is basically haloform reaction. Okay. Okay, so haloform, if you are having, let's say, ketone or methyl ketone more precisely, RCOCH3. Okay, if you give NaOX type of hypohalide type of compound, you will end up with the haloform RCOO minus Na plus, that is also an oxidation reaction, plus CHX3. This precipitation you will get if you are using iodide type of thing. Okay, so see one example, let me show you. Let's say I am having RCO, same thing, RCOCH3. Let's say I am using NaOI, sorry. So you will end up with RCOO minus Na plus you will get the yellow precipitation of iodoform. You will get some yellow precipitation of iodoform. Okay, I guess it's clear. This is your haloform reaction. Okay, so yes, let's proceed further. Okay, so here we will proceed with the aldol condensation reaction. So aldol condensation, what is the primary criteria? It's definitely I must have alpha hydrogen, right? So this is my carbonyl carbon. With respect to this is the alpha position. In this alpha position I must have one hydrogen, right? Then it will undergo aldol condensation reaction. It will give you the beta hydroxy aldehyde compound, beta hydroxy aldehyde type of compound. On being further dehydration, it will give you alpha beta unsaturated aldehyde. See, in the alpha and beta you are having one unsaturation. Okay, so similar thing can be done in the ketone as well. Now cross-aldol also can be possible with two different aldehyde, but the mechanism is same, and again you will end up with some beta hydroxy product and definitely alpha beta unsaturated carbonyl as well. Okay, let's proceed other reaction, that is the Cannizzaro reaction. Now Cannizzaro reaction, what is the condition? You will not be having any kind of alpha hydrogen out there. So what is the condition for aldol? There must be alpha hydrogen, but in Cannizzaro you should not have any alpha hydrogen. Okay, so this Cannizzaro reaction is a kind of disproportionation type of reaction. So aldehyde once will be oxidized, one will be reduced. So you have to give concentrated KOH, so it will be reduced to alcohol as well as it will be oxidized to its carboxylate form. Okay, so here you can see this is benzaldehyde. There is no alpha hydrogen at all. If you are giving concentrated NaOH, then a concentrated base you have to treat a little bit heat. You will end up with alcohol, benzyl alcohol and the benzoate. I guess it's clear to you. Let's proceed. Okay, so part 3 is the carboxylic acid nomenclature, structure and preparation. We will proceed. In the preparation you can see from 1 degree alcohol and aldehyde, from alkyl benzene, from nitrile amides and Grignard reagent, acyl halides, esters. Okay, this is the nomenclature, just basic nomenclature with the common names are there. You can just go through from your NCERT. This is with the aromatic compounds. You can see phthalic acid, you can remember. Okay, let's proceed with the structure. So basically carboxylic acid, it exists in the resonating structure. You can see 3 resonating structure is possible. So this bond will jump here, you will get a negative sign here, this carbon will be positive, again this bond can come here, the double bond can be shifted in this position. So it exists in resonating structure. Okay, let's proceed. Preparation, here in the preparation we can proceed with 1 degree alcohols and aldehydes. We can proceed with from alkyl benzene, from nitriles and amides, from Grignard reagent, from acyl halide and anhydride, and from esters. Okay, so yeah, let's proceed with the preparation. So I have to come up to RCOOH. Okay, so from where I should start, let me just check once, from 1 degree alcohol and aldehyde. Okay, let's start from alcohols. So if you start from alcohol, let's say RCH2OH. Okay, so from here, how you should go? You can give simple alkaline KMNO4. Alkaline KMNO4 in presence of H3O plus, or you can give, let's say, CrO3 in presence of H2SO4. Fine. Now let's say I am having, okay, let me just check, alkyl benzene. Okay, so let me just take methyl benzene. So if I am taking methyl benzene, how I can come up with this? Simple KMNO4 I will give, KMNO4 in presence of KOH, little bit H3O plus, that's it. Okay, this is the thing. Next, from nitriles and amides. Okay, so if I'm having, let's say, nitriles, RCN. So if I'm having RCN, if I give a little bit H plus or OH minus heat, I will end up with amide, RCONH2. Okay, from amide to here, simple hydrolysis, H3O plus. Okay, in presence of heat. That's it. Okay, next from Grignard reagent, I guess. Okay, chalo, Grignard reagent, RMgX. Here I will give dry ice, that is carbon dioxide. C double bond O, here I will give RMgX. Okay, I will end up with RCOOMG. Okay, OMgX. Now you know last step is H3O plus. If you give, we will end up with carboxylic acid. Next, acyl chloride we will proceed. Let's say I am having RCOCl, right? Just little bit water will work here. Just give water, or else you can just give a little bit OH minus or water. It can come up to RCOO minus and then protonation, H3O plus, anything. Okay, that's it. Anything I missed? From ester. Okay, from ester, where I should write? Here. Let's say I'm having benzene CO OC2H5. Okay, simply just H3O plus will work here. Okay, it will give you the acid. Okay, I guess it's clear to you. This is the entire preparation of carboxylic acid. Okay, let's proceed. Okay, one problem. What is the common name of the simplest dicarboxylic acid? So simplest dicarboxylic acid, whenever two carboxylic acid unit, they are attached to each other. Okay, this is nothing but the oxalic acid. Okay, proceed. Carboxylic acid, here physical properties and chemical properties. In chemical properties, again from 1 degree alcohol and aldehydes from alkyl benzene, nitriles. Okay, these things we will study anyway. Physical properties, you can see boiling point. Carboxylic has acid, definitely it is having higher boiling point than that of the aldehydes and ketones because of the intermolecular hydrogen bonding, because one carboxylic acid can be attached with another with intermolecular hydrogen bonding, right? That makes the boiling point higher. Next, solubility. Solubility definitely decreases with increase in the alkyl chain, right? Higher the chain member of the chain, alkyl chain, then it becomes very less soluble in water because of the hydrophobicity. That's it. Okay, next we will proceed with the chemical reaction. You can see it can involve the cleavage of OH bond, and it can involve the cleavage of CO bond, or it can involve the entire CO group, entire COH group, or the reaction involving the hydrocarbon part. Means, let me just show you. Let's say I am having this thing, RCOOH. Okay, I can cleave here, I can cleave here, okay, I can cleave here, okay, I can react with this full thing, I can react here. Okay, this is the thing. So yes, one by one we will proceed. First, cleavage of OH bond we will study. Acidic nature, definitely hydrogen, oxygen will release hydrogen, definitely it will show acidic nature. Reaction with metals and alkalis. There in CO bond cleavage we will study anhydride formation, we will study esterification, reaction with PCl5, PCl3 and SOCl2, and reaction with ammonia. The reaction involving COH group, you can see the reduction, decarboxylation, okay, and in the reaction in the hydrocarbon part you can see halogenation, that HBZ reaction we will study there, and substitution as well. Okay, so now let's proceed with these reactions. Okay, cleavage with OH bond. So cleavage with OH bond will show acidic nature at first, and definitely the reaction with metals here you can see. So more acidic than phenol, definitely an electron withdrawing group increases the acidity. So if you are having any electron withdrawing group attached to the carboxylic acid, it pulls the electron cloud towards itself. As a result of this, oxygen hydrogen bond breaks quickly and acidity increases. So this is the order of the electron withdrawing group. Here you can see if you are having CF3, if you are having CF3COH, it is having the maximum acidity because CF3 is having maximum electron withdrawing power. Then correspondingly you can go through with CCl3, then CHCl2, then NO2, like that. Okay, this is the overall order of the acidity if electron withdrawing group is present. Now here you can see this is basically the reaction with metal. This thing I guess is not visible, wait. Okay, so if you are having carboxylic acid, it can react with sodium metal as well as NaOH as well as NaHCO3, and you will get the carboxylate. Okay, if it reacts with only metal, you will get hydrogen gas. If it reacts with base, means NaOH, you will get salt plus water. If it reacts with NaHCO3, you will get definitely salt, water plus carbon monoxide. Okay, let's proceed. Cleavage of CO bond. So once it's the matter of CO bond, it's definitely anhydride formation, esterification, PCl5, PCl3 and SOCl2 reaction, and reaction with NH3. So let's proceed with these reactions. So first let's see anhydride formation. Okay, so one by one we will proceed. Let's say anhydride formation, esterification. Okay, first let's say anhydride formation. Okay, so here what I can do, I can take similar type of 2 carboxylic acid, let's say RCOH, here HOCOR. So here one OH and one hydrogen, it gets released in the form of water, and you will end up with Okay, I have to give the reagent either H plus heat, or I can give P2O5 as a catalyst or heat. Okay, I will end up with the anhydride formation. Like that. This is the anhydride. Okay, next we can proceed with the esterification. That was there, no? Esterification, yes. Next we can proceed with esterification. Okay, here also I can do the same thing, that is RCOOH. Along with that I can add one alcohol, HOR prime. Okay, here catalytic amount of acid is required, and you can end up with the A star group, RCOO R prime plus water. Next you can just proceed with the PCl5, PCl3, those reagent. Reaction with PCl5, PCl3 and SOCl2. Fine. So one by one let's proceed. Let's say I am having RCOH. Okay, first if I give PCl5, then I will end up with RCOCl plus POCl3 plus H2O. Okay, next I am having, let's say, PCl3. Okay, again I will be getting the same thing, RCOCl plus H3PO3 I will get as a byproduct. Next I can react with SOCl2. Okay, it will give you RCOCl plus SO2 plus HCl. Okay, next what I can proceed with, reaction with ammonia. Okay, so next we can proceed with reaction with ammonia. Reaction with NH3. Okay, so let's say I am having CH3COOH. Let's say I am reacting with NH3. Okay, it will give you the ammonia salt at first on being heated. So now you will get it something like this at first, CH3COO minus and NH4 plus. Okay, on being further heated, it will release 1 unit of water and you will end up with some amide compound, that is CH3CONH2. Okay, so same thing can be happened with benzoic acid as well. Okay, now one thing let me show you, if I am having dicarboxylic acid like this, COOH, here also I am having COOH. So if I am treating this thing with NH3, okay, so here also you will end up with this thing, COO minus NH4 plus, here also COO minus NH4 plus. Now what will happen, if you heat this, it will be converted to amide, right? So CONH2 here, here CONH2. Now if you further keep heating this system, this will release 1 unit of ammonia and it will form the phthalimide. This is basically phthalic acid, right? This is basically phthalic acid. Okay, from here I can come up with phthalimide. Okay, this is basically phthalimide. Okay, I guess it is clear to you. This is the reaction with ammonia. Okay, let's proceed for the reaction with COH group. Here we can proceed with reduction and decarboxylation. Okay, so once we are doing the reduction reaction, just let me show you. So reduction we can perform with LiAlHF4, lithium aluminium hydride. Let's say I am having RCOH. I am giving lithium aluminium hydride, okay, or ether or B2H6. Okay, I can end up with alcohol RCH2OH. This is the reduction. Decarboxylation reaction, let's say I am having sodium salt of carboxylate ONA. If I give soda lime, right, soda lime means NaOH plus CaO. Okay, then it will form RH plus Na2CO3. This is decarboxylation. Okay, I guess it is clear. Next you can see reaction of the hydrocarbon part. First is halogenation, next is substitution. So halogenation, what we can do here, I can perform HVZ reaction, Hell-Volhard-Zaleski HVZ reaction. So what is this reaction? Let's say I am having RCH2COOH. Okay, here if I give any kind of X in presence of red phosphorus, okay, X can be, you know, chlorine or bromine. Okay, a little bit water is also needed. Then it will form alpha halocarboxylic acid. Okay, so this is my alpha carbon, right? So in the alpha position I will get the halogen RCHCl. Here I am having COOH, alpha halocarboxylic acid. This is your HVZ reaction. Okay, next you can see substitution reaction. Let's say I am having again benzoic acid. Okay, here I am getting here I am giving Br2 in presence of FeBr3. Okay, so carboxylic acid is basically meta substituted group, right? So I will get bromine substituted at the meta position. Okay, now here you can see one more substitution. Let me show you nitration reaction. Concentrated H2SO4 plus concentrated HNO3. Okay, I will end up with meta position nitro substituted, here carboxylic acid COOH. This is all about the substitution. Okay, so I guess clear. This is all about the entire chapter aldehyde, ketone and carboxylic acid. We will soon come up with the previous year question. By that time, please don't forget to like, share and subscribe. If you are having any doubt, please comment me below. Thank you so much for watching.